Hello everyone. Today we will talk about polynomials. Chapter 2, class 9, chapter name polynomial. So the polynomial is what is the meaning of polynomial? Polynomial, the word made up of two words, poly and nomial. Poly, it means many, and nomial, it means terms. So the algebraic expression made up of many terms is known as polynomial. That is, we can categorize the polynomial on the basis of two things. One, on the basis of terms, and second, on the basis of its degree. So today we'll talk about the categorization of polynomial, classification of polynomial on the basis of its term. Let's start with the TCE presentation, and we'll discuss about it in between.
Take a look at the following algebraic expressions. Notice that these expressions have only one term. A term may simply be a number or contain variables or be a product of two or more variables. These expressions can even be a product of a number and a variable, such as minus 11ab, 3a raised to the power of 3b, 7z. Such algebraic expressions with one term are called monomials.
So here we can see the monomials, that is the smallest polynomial with single term. It could be any number, any constant number. It could be a single variable, say x or y or z. It could be the product of two variables, that is xy square, or it could be the product of a constant and a variable, or constant and two or more variables. Say minus 11ab, where minus 11 is constant and a and b is variable. 3a cube b, where 3 is constant, a cube b is a cube and b are variable. Or 7z, where 7 is constant and z is variable. Or we can say 3xyz, where 3xyz, xyz are set of constant and 3 is variable. So if it is in case of multiplication, it is to be considered a single term, irrespective of 3x, y, and z as four different numbers or different constant and variable. It will be considered as a single term and called monomial. So algebraic expression with one term are called monomial. Now, if
An
we'll,
important thing to notice here is that the power of the variable is always a whole number.
and the most important thing here,
Let's see what happens if we add some operators to these.
most important thing to be observed here is the power of all the variable is a whole number, that is a non-negative integer. It could be 0, it could be 1, 2, 3, and so on, but not a negative number, neither a negative number nor a fraction. The power of a variable should be a whole number. Now, if we'll put negative or positive sign, that is, if we'll add or subtract two or three monomials, or two, three, or more monomials, it will be considered as a polynomial. Just have a look.
Now, these algebraic expressions are a combination of two or more than two monomials. Algebraic expressions made up of two or more than two monomials and that are combined using addition or subtraction are known as polynomials. A monomial is also a polynomial, but with one term. Here are some more examples of polynomials.
So here we can see minus 11ab minus 3a cube, which consists of two terms. 7z plus 6 minus xy square plus x, it consists of four terms. 7p square r, it consists of one term, that is 7p square r is considered to be one term, as there is a single three different digits although, but there is no positive or negative sign in between. This should be considered as monomial. So algebraic expression made up of two or more than two monomials and that are combined using addition or subtraction sign is known as polynomial. A monomial is also a polynomial, but with a single term. So monomial is also polynomial. Monomial with two monomials combined with addition or subtraction sign is also a polynomial. Two or more than two, that is 3, 4, and so on. So the polynomial is any algebraic expression whose power or any constant whose variable's power is a whole number is a polynomial. Single term, two term, three term, four term, five term, six term, any number of terms. So it will be a polynomial. Now we'll have a look on examples of polynomial.
How would you know if an expression is a polynomial or not? Let us look at some examples of expressions which do not qualify as polynomials. This is not a polynomial because the variable b has a negative exponent. Do you think that this would qualify as a polynomial? No, it wouldn't, since the variable z is in the denominator.
So here we can see four examples. First one is 8b raised to power minus 2 plus 5. Because the power of variable is a negative number, this is not a polynomial. This is a simple algebraic expression. 9 upon z square plus 1 by 5, the second example. If we'll have a look on z square is the denominator. If we'll apply the exponent identity, the negative exponent identity, we'll keep z square in the numerator. It will become 9z raised to power minus 2. Because the power of z is negative, it is also not a polynomial. In the third one, under root x plus y, the power of y is 1, but power of x, if we remove this under root, it could be written as x raised to power 1 by 2. So because x raised to power 1 by 2 is here, which is not a whole number, that is why this is also not a polynomial. And the fourth one, 4x raised to power minus 1 by 2, because the power of x is minus 1 by 2. Minus 1 by 2 is not a whole number, it is a rational number. So minus 1 by 2 is not a whole number, that is why 4x raised to power minus 1 by 2 is not a polynomial.
It is fraction. To sum up, any expression with a variable that has a negative or fraction exponent cannot be defined as a polynomial. Click the next button to take the quiz.
So
Now
here we
that we
can
have learned about polynomials, we will take a short quiz. Click the book to launch the quiz.
So here we can sum up this like any expression which have a negative exponential power or fraction in the power of exponent will not be a polynomial. Just have a look. We'll discuss a few questions to better understanding of polynomial.
Determine whether the following expressions are polynomials or not.
See, 5x.
Select the correct option and click submit.
We have 5x raised to power 1 by 2 y. Because the power of x is 1 by 2, which is in the fraction form, this is not a polynomial. So this cannot be able to, we cannot be able to consider it as polynomial.
That's correct.
Now the second question is
Select
under
the
root
correct
z.
option and click submit.
Under root z, if we'll write it in the exponent form, it will be z raised to power 1 by 2. So because the power of z is in the fraction form, this is not a polynomial, as we have the condition that the powers should be a whole number. The power of z is 1 by 2, which is a fraction. This is not a polynomial. Under,
That's correct.
as under root z can be written as z raised to power 1 by 2, since the exponents of variable is not a whole number, this is not a polynomial. Now, next question. 2b raised to power minus 2 plus c.
Select the correct option and click submit.
Here, the variable is b and the power of b is negative number minus 2. As b raised to power minus 2 and minus 2 is not a whole number, this is also not a polynomial. So we'll click no here and then we'll submit it.
That's correct.
Now next question. 2a plus 3b plus 5c. Sorry. This is no, as power of b is negative number.
Select the correct option and click submit.
C. The power of a, b, and c is 1. Because the power of a, b, c is in the whole numbers only, this is a polynomial. So we'll click yes here and sum. It is polynomial as the exponent for all the variables is a whole number. Next question. Next question, we have 2z raised to power 2 plus x raised to power 2 by 3. Looking at the first part of the power of x is 2 by 3. As the power of x is not in the whole number, this is not a polynomial. So we click no here and then we'll submit. And the initial slide only or initial phase only, I told you that every constant number is a polynomial, as we can represent 5 as 5x raised to power 0. Any constant number you can represent as 5 into x raised to power 0. We can multiply by x raised to power 0 to any number. That is 5 can be represented as 5x raised to power 0, because the power of the value of x raised to power 0 is 1. So this is a polynomial where power of x is 0 and 0 is a whole number.
That's correct.
Next we have 3x plus 2.
Select the correct option and click submit.
3x plus 2, the power of x is 1. So 3x plus 2 is a polynomial because the power of x is in the whole number. Now question 8 is 5x cubed plus 2x square minus 3x minus 16.
Select the correct option and click submit. Select the correct option and click. Select the correct option and click submit.
So 5x cubed plus 2x square minus 3x minus 16, as the power of all the numbers is in the form of whole numbers only. X cubed, 3 is whole number, 2x square, 2 is whole number, 3x, x raised to power 1 is a whole number, and minus 16 can be considered as minus 16 x raised to power 0, which is also a whole number. So this is a polynomial. If we submit. Now the ninth question is 0. Is 0 the polynomial?
Select the correct option and click submit.
Yes, every whole number or every natural number or every integer can be, or all the numbers, I mean whatever it is, rational, irrational, all the numbers are polynomial. So 0 is also a polynomial, though 0 is a very special type of polynomial. When we'll talk about the degrees of polynomial, we'll talk about 0. So this is also a polynomial, as we can represent 0 as 0 x raised to power 0, even 0 x raised to power 10, 0 x raised to power 100, 0 x raised to power any number. Because if we'll put 0 x raised to power 7, and whatever the value of x, if we'll multiply it to 0, that will become 0 automatically. So this is also a polynomial. We'll click yes and then submit. It is a polynomial, as whole numbers are polynomial. Though it's not about whole number, all the numbers, all real numbers are polynomial. Now question number 10.
Select the correct option and click submit.
5 by 6 x raised to power minus 1 by 2, as the power of x is in not a whole number, the power of x is in the form of fraction minus 1 by 2. This is why this is not a polynomial. So we'll click no and then we'll submit it. So here we got a few examples of polynomial, that which are polynomial and which are not. We have a look that what is polynomial all about, what is the condition to make a polynomial, what could be the exponential form of the polynomial, why the polynomial, why the algebraic expression is not a polynomial, why it is a polynomial, because the power of variable should be a whole number. If it is not a whole number, if it is in the form of fractions or negative numbers, integers, negative integers, then it will not be a polynomial. Now we'll talk about the values of polynomial and zero of polynomial. So what is value of polynomial? Say if we have 2x plus 3, and if I'll put x is equals to 1. So 2x plus 3, if I put x is equals to 1, 2x will be 2 into 1, that is 2, and plus 3. 2 plus 3 is what? 5. So 2x plus 3 at x is equals to 1 will become 5. This is the value of polynomial at x is equals to 1. Just have a look on PCE presentation.
Consider the given polynomial. Here x is our input variable and can take on any value we assign to it. Minus 2x plus 5 is our output value. Here, the output or value of the polynomial p of x depends on the value of our input or the value we assign to x. Let us now see how the input value determines our output value by learning how to find the value of a given polynomial. Here p of x equals minus 2x plus 5 is a polynomial in x.
So here we have seen that if we'll put x is equals to 2, the value will become minus 4 plus 5, that is minus 2 into 2 will become minus 4, and plus 5. Minus 4 plus 5 will give you 1. So value of polynomial at x is equals to 2 is 1. What if we'll put the x is equals to minus 1? So if we'll put x is equals to minus 1, minus 2 into minus 1 will become 2, and 2 plus 5 will give you 7. So value of polynomial at x is equals to minus 1 will be 7. Just have a look.
Polynomial at x equals minus 1. First, we simply substitute x equals minus 1 in the given polynomial and then simplify the right-hand side of the equation. Here p of minus 1 is 7. Let's look at another example where we must evaluate the polynomial at x equals b plus 3. Remember, we must follow the same steps here as well. First, substitute x equals b plus 3 in the given polynomial and then simplify the right-hand side of the equation.
So here we can see if we'll put x is equals to b plus 3, that is minus 2 times of b plus 3, will multiply minus 2 inside the bracket. It will become minus 2 into b minus 2b, and minus 2 into plus 3. 3 to the 6 with negative sign because minus 2 is negative. So it is minus 6 plus 5. 2b is a variable, so we'll keep 2b as it is, minus 2b as it is in fact. And minus 6 plus 5, because negative number is minus 6 and which is a greater number, bigger number. So we need to subtract 6 and 5, the answer will be 1. But we need to keep the sign of the larger one, and larger one is negative. So the answer will be minus 2b minus 1 at x is equals to b plus 3.
To get the answer. Here, p of b plus 3 is equal to minus 2b minus 1. Note that in all three examples, we use the same polynomial, but assigned different values to x. Since our input values were different, we got a different answer or output in each case. Hence, we can say that the value assigned to the variable x in this case determines the value of the polynomial.
So here I need to plug in something, that is the polynomial is x square minus x minus 6. Due to technical issues, it as x2 minus x minus 6, but it is x square minus x minus 6. So we'll consider it as x square minus x minus 6 here, as well as in the solutions when we substitute the value as x is equals to minus 2, 1 and other. X is equals to minus 2, 1 and 3. So just have a look. When you substitute the value, what will be the answer?
To do this, we substitute these values for x in the given polynomial. to find the respective values of p of x. Note that when x takes the values -2 or 3, the value of the polynomial becomes
So here you can see we substituted x equals to -2, the value of that polynomial has become 0. Whereas in p is equals x is equals to 1, that p of 1 is -6 and p of 3 is 0. So here we can see at -2 and 3 the polynomial becomes 0. So this is what the 0 of polynomial, if we can define it as the value of x at which the polynomial get vanished, or the value of polynomial becomes 0, is known as 0 of polynomial. So here we can conclude that x is equals to -2 is a 0 of polynomial px, and x is equals to 3 is also a 0 of polynomial px, x square minus x minus 6. Here we can see 3 square, 2 square is -2 square is 4, minus plus 2 minus 6 is 0, and here 1 square is 1, -1 minus 6, -1 and plus 1 cancel, answer will be -6. Here we can see 3 square is 9, -3 -6 and -3 will become -9, and 9 minus 9 will become 0. So here we can define 0 of polynomial as the value of x at which the value of polynomial become 0.
A zero of a polynomial is a value of the variable for which the value of the polynomial becomes 0. Here's an easier way to look at it. Now, let's see how we can find the zero of a polynomial.
So we can see if we need to find out the value of any polynomial, the value of 0 of any polynomial, we need to equate it with this 0, and we need to find the value of x in that case. So we have 5x plus 9, we equated it with 0. When we transport this 9 towards right hand side, it will be 5x is equals to -9, or value of x will be -9 by 5. Ignore this r typed here. This is when we will talk about the remainder theorem and factor theorem, we'll talk about this. Just ignore it right now. So 5x is equals to -9, and value of x is -9 by 5. So this x is equals to -9 by 5 is 0 of that polynomial. If we substitute x is equals to -9 by 5, the polynomial will become 0. Have a look.
We determine this by equating the polynomial to 0. The value of x obtained is -9 upon 5. Now let's verify our result by substituting back -9 upon 5 in place of x in the polynomial. We see that the value of the polynomial obtained is 0.
Here the 5 and 5 will get cancelled. We'll have -9 plus 9. -9 plus 9 will become
the
0.
zero of this polynomial.
So x is equals to -9 by 5 is 0 of polynomial.
To find the zero of a polynomial.
So x is equals to -9 by 5 is 0 polynomial, because at x is equals to -9 by 5, the polynomial becomes 0. So there is no change in 0 and root of the polynomial. The 0 is polynomial. 0 is in the case of polynomial expression. Whereas if it is equation, if in the right hand side, if it consists of is equals to sign, and there is some value in the right hand side, or px is equals to 0, it will become polynomial equation. In polynomial equation, the value of x which satisfied the answer, or which satisfies the right hand side, is known as 0 of polynomial.
Satisfies the polynomial equation p of x is equal to 0 is called a root of the polynomial equation. This will help you understand this better. Let's consider this polynomial equation. This equation is satisfied when x is equal to 1 upon 5. So x is equal to 1 upon 5 is a root of this polynomial equation.
Polynomial is the equation. This is polynomial with us 1 polynomial expression. 0 is -1 by 2 is an equation. 2 is equals to 0, and x is equals to -1 by 2 the root of polynomial equation. There is no in polynomial equation, and there is no the 0 polynomial expression and root of polynomial equation. So here we have talked about the polynomials. What are polynomials? What is the identification of polynomial? What are zeros of polynomial? What is zero of polynomial? How to find it? In next class, we'll be talking about the zeros of polynomial and question based on zero of polynomial and value of polynomial. So we are almost done with exercise 2.1 and 2.2 based theoretical part. In next class, we'll talk about the practical part of 2.1 and 2.2. Thank you very much.